Number 28. The vector u equals 6, negative 4 is orthogonal to the vector v equals what? So this vector, 6, negative 4, what this basically means is if you have a coordinate plane, I'll say this is the origin at 0, 0, and you plotted the point 6, negative 4. So I'll say that's around here. And you drew an arrow from the origin to that point, that would be this vector u. This would be u equals 6, negative 4. And then what it means to be orthogonal is it's pretty simple. All it means is that it's going to be perpendicular. So if you have a vector like this, it's just going to be perpendicular. And the way you find out if something is orthogonal is when you take the dot product, you end up with 0. So a little bit about what dot product is. Let's say you had two vectors, 1, 2, and then dotted with 3, 4. The way you would find the dot product is you just multiply the terms that are in the same positions and then add them together. So 1 times 3, that's 3. 2 times 4, that's 8. So if you added them together, the dot product of this is 11. And this is very simplified. There's a lot of nuance behind this idea, but this is really all you have to know for this problem. So that's kind of what the dot product is as an operator. And so now we just have to find out which of these ends up with a dot product of 0. So on these ones, we have to check a bunch of them. I always like to start towards the end because for some reason, those tend to be the answer. So if I take 6, negative 4, and then dot that with negative 4, 6, let's see what happens. So 6 times negative 4, that's negative 24. And then negative 24 and 6, that's also negative 24. So that's not going to be 0. Now, what if I did 3, negative 2? So it's not E. What if I did 3, negative 2? Let's see. 6 times 3, that's 18. Negative 4 times negative 2, that's 8. And so, nope, that's not going to be 0. So we're striking out a little bit right here, but it's still a good strategy because this tends to be the way it works. Let's see. Now let's go to 2, negative 3. Let's see. 6 times 2, that's 12. Negative 4 times negative 3, that's also 12. Okay, so maybe we should have started at the beginning. But usually it's a good idea to start towards the end. I'm just getting unlucky this time. All right, let's try negative 2, 3. Let's see, 6 times negative 2, that's negative 12. Negative 4 times 3, that's also negative 12. So this is a really bad example, but it looks like this is one of the few cases where it actually is the first answer. But let's just double check. So we do 2, 3. 6 times 2, that's 12. Negative 4 times 3, that's negative 12. And so in the end, yes, we get 0. Yeah, so I know this time the rule didn't really work. A lot of times he likes to put it at the end, but I guess he figured out that people catch on to this idea, and so he mixed it up a little bit and put it at the beginning. But it's still a good strategy to go for the last answer first on these ones where you just have to guess and check pretty much. So anyway, if you have any questions from other tests, make sure to leave a comment and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.